Hi, welcome to our next Level 3 probability distributions video. We're going to continue talking linear combinations. Now in the last video we talked about the expected value of mean and we added or multiplied numbers by the x and created new expected values or means. We're going to do the same trick, but we're going to use the variance or standard deviation. Alright, well example 1 comes back to Mr. Pythagoras in his maths class and the probability distribution table. We can create the mean or expected value of x by multiplying each of the values of x by the probability and adding them all up to get e of x equal to 3.1. We then have showed you in a previous video how to calculate e of x squared, and we use e of x squared and e of x to calculate a parameter called the variance of x, which was 2.99, and then we can square root the variance to get the standard deviation of 1.73. All right, let's move on to our first official example of the video. We're going to calculate the variance of 3x as well as the standard deviation of 3x. What that means is we're going to take each of the x values and multiply them all by 3 and then calculate the new variance and the new standard deviation. Now we could do this the long way like I showed you just before, or we're going to learn some tricks with some formula that are provided to speed this up. Basically, to calculate a new variance when all numbers have been multiplied by a number called a, we take the old variance and we multiply it by a squared. In this case, a is 3, everything's getting multiplied by 3. So 3 squared times the old variance. Now the old variance, remember, we worked out before was 2.99, so we're going to multiply that by 3 squared. 3 squared is 9. 9 times 2.99 gives us a new variance of 3x equal to 26.91. Then we can just square root that to get the standard deviation. The square root of 26.91 gives us 5.19 rounded to 2 decimal places. All right, let's move on to example 2. Let's calculate the variance of x plus 4 and the standard deviation of x plus 4. So once again, what we're doing is taking all x values and adding 4, and then we're going to calculate the new variance and new standard deviation. Well, again, let's use a trick instead of doing it the long way. And the trick is actually quite simple here. Whenever we plus or minus some number called b onto our x values, the variance doesn't change. That's because variance is a measure of spread. And if every value gets added on 6 or added on 1 or something, then the spread doesn't change because all values get added on equally. Just like this box and whisker graph here shows, the bottom blue graph, which is the old data x, if I added 1 to every bit of data, we have an x plus 1, which is the top red graph. It's the same spread, the same shape, the same distribution. It's just everything's shifted along one. So our spread, our variance, our standard deviation doesn't change if we add or subtract something. So basically, even if we add 4 to all values of x, we basically stay with the same variance. Now the old variance was 2.99, so our new variance is 2.99. And therefore we can square root that to get a standard deviation, which is going to be the same as what we had before, of 1.73. So keep that in mind. When we add or subtract a number to all values of x, our variance doesn't change. All right, our final example is just to mix those two together with a linear combination. So all data of x is going to be multiplied by 5, and then we subtract 1. We're going to work out the new variance and standard deviation. Well, we need to remember the trick. Because we're multiplying everything by 5, we're going to take the old variance and times it by 5 squared. But then that minus 1 doesn't change anything else because we don't need to change the variance when we add or subtract. So all we have to do is multiply it by 5 squared. So our old variance was 2.99. So multiply that by 5 squared. 5 squared is 25. So times that by 2.99 to get a variance of 74.75, and then we can square root the thing to get our standard deviation. The square root of 74.75 is 8.65 rounded to 2 dp. Thanks for watching.